Hey guys, so we're going to work on another sample FRQ. This time we're working on FRQ4. FRQ4 is no calculator allowed, so you will be doing this all by hand. And this question, it's like I said, it's always going to be pretty much the same. This one is going to be full of manipulating equations. So whether they ask you to solve or maybe like rewrite, simplify, but you're just getting an equation and you're moving things around. There won't be any like sentences that you have to write for this one. Okay, so let's look at the first part. The functions g and h are given by, so we give our two functions. Part A1, solve g of x for pi over 6 for values of x in the domain of g. Okay, so here's my equation. And they want to know, like, solve for x whenever g of x equals pi over 6. So we're just going to replace that there and then solve. So I'm going to work this out on my answer sheet. And they do give us kind of a lot of space here. So pi over 6 is equal to 2 sine inverse x. Okay, so if we're solving, our goal is to get the x by itself. So first thing I want to move is 2. So we're going to divide both sides by 2, but essentially, I think the easier way to do this is to multiply by 1/2, because half of 2 is 1, and that'll cancel. And then if I do that to the other side, multiplying fractions is really easy. So this would be pi over 12 equals sine inverse of x. Okay, then I want x to be by itself. So this sine inverse, that is the next thing that I want to move. So sine inverse is an actual function. So there's not like an opposite operation I can do. I can't just like divide by sine inverse. I have to undo that function, which means I need the inverse. But the inverse of an inverse is just a regular function. So I'm going to take sine of both sides, and that'll cancel. But got to do that over here as well. So now I have sine of pi over 12 is equal to x. So x is by itself now. So one last thing is, if this was something that you could easily find on the unit circle, say, they would expect you to be able to give an actual angle here, like give the actual value. But pi over 12 is not one of our unit circle values, so this is not something that they expect you to have memorized. So you could just leave it exactly like that. I wouldn't box it in, but I would just kind of write it separately over here. X equals sine of pi over 12. Okay, and then for part A2, similar, just different equation. Solve h of x equals 8 for all values of x in the domain of, I think this should be h. Okay, so here's our function. 3 minus 2 natural log of x, but we're going to make that equal 8. So 8 equals 3 minus 2 natural log of x. Okay, so same thing. If we're solving, we need x to be by itself. So first thing I would move is that 3. And the way we move it is by subtracting. 8 minus 3 gives me 5. So now I have 5 equals negative 2 natural log of x. Okay, now negative 2 is a coefficient in front of that logarithm. So I am going to divide by negative 2 on both sides. And then that'll get me negative 5/2. Yes, it'll be okay if you change that to a decimal. So say you wanted to put negative 2.5. That's 100% okay. I just prefer fractions. Okay, and then last thing is I want this x to be by itself. So I need this logarithm to go away. So there's a trick that we do is we change it to exponential form. So remember, logarithms and exponents are very, very similar. So I want to write this with my laser pointer just as a reminder. If we have log base b of x equals y, you can rewrite that exponentially as b to the y power equals x. So the base stays the same in both of them, but the x and the y switched order. So we're going to do the same thing here. The thing is, this is natural log, so you have to remember that natural log is equal to log base e. So to rewrite this, I would write e to the negative 5/2 power equals x. So this one had a base e, raise it up to this power equals x. So same thing as the part right before this. If this was something easily solvable, they would expect you to do it. So say you had like 5 to the 3rd power, they would expect you to solve that. But this one, there's no way you can do it without a calculator, so just leave it like that. Okay, next part. Part B, functions j and k are given by, so there's our functions. Rewrite j of x as an expression involving secant and no other trigonometric function. So this is the one where you need to know your identities. And then it says, show your work that leads to the answer. So they expect to see your steps of how you get there. So I'm going to rewrite this on my answer document, and then we'll keep going from there. So tan sine over 1 minus cosine. Okay, so we have tan sine over 1 minus cosine squared. Okay, so anytime I see a trig function that's been squared, so this one, and there's also a 1 close by, so there's a 1 right here, I automatically think of Pythagorean identities. Now, there's a Pythagorean identity that says sine squared plus cosine squared equals 1. So what they did here is they got this cosine and they subtracted it over to the other side. So then it cancels. But what's left over is sine squared. So that whole denominator can be rewritten as sine squared. Which now hopefully we can see. Sorry, I did my notation all kinds of weird. We should match what they did. Okay, but now we can see is that there's sine at the bottom and on the top. So we can cancel out, but not the entire thing because the bottom is squared and this one's not. So we're only going to cancel out one of them. So this would be tan x over sine x, no longer squared. Okay, but what did they ask us to get to? They want us to be able to get to secant. So that means that we're not done yet. So whenever you're stuck and you don't know what to do, change everything to sine and cosine. So tangent, I know that I can change it to sine and cosine. So tangent is sine divided by cosine. I'm going to put my equal sign over here. And then this sine, since it's at the bottom, so you can think of this as like there's a times 1 here and a times 1 here. So we had tan over 1 and 1 over sine. Okay, and then now hopefully you can see that the sines get canceled. So this is 1 over cosine, which is secant. And that is what they wanted us to get to secant x. Okay, part B2, it's also one of those where they want us to rewrite our expression, but they want it in the form of a to the ax plus b power, where a and b are constants. So I need to get this equation and make sure that everything has a base of 5. So I'm going to rewrite this, and then we'll start simplifying. So this is part 2. Okay, so it was 25 to the x plus 3 times 5 to the 3x minus 2 all over 5 to the x. Okay, so like I said, we want to make sure that everything is the power of 5. So that's a power of 5, that's power of 5. But this is a 25, so we need to rewrite that. I know that 25 is the same as 5 squared, but then it already had x plus 3. So I'm actually going to get this 2 and multiply it in. So that'll be 2x plus 6. Okay, and then we're still multiplying by 5 to the 3x minus 2 and dividing by 5 to the x. Okay, so let's do the numerator next. So now that everything's the same base, when things are being multiplied, you add their exponents. So the numerator is now going to be 5 to the 5x plus 4. So what I did is I combined like terms. 2x plus 3x is 5x. Negative 6 minus 2 is 4. And then bottom, I'm going to leave that the same for right now. But that is the last thing that I need to simplify. Now I'm dividing. When I'm dividing, I subtract exponents. But we're going to do like terms. So I have a 5x and an x. So that's going to become a 4x. And then the constant is just going to stay a 4. So actually, I kind of wish I had wrote it over here. So I'm going to move it over. The answer is 5 to the 4x plus 4. So I know I'm done because it says that your answer needs to be in that form. And that's what I have. A and B are both 4. Okay, and then last part C. The function m of x is given by, and they give us our equation here. Find all input values in the domain of m that yield an output value of 0. Okay. So output correlates with y. So basically they want to know when it equals 0. So I'm going to write that down. 0 equals, it was 2 natural log of x minus natural log 7x minus 12. Okay, so properties of logarithms. When you have a constant in the front, that becomes a coefficient, or that becomes a exponent. So natural log of x squared. Okay, but now I want to combine these as well. If I have a minus sign, that means I need to divide those arguments. So now I have 0 equals natural log of x squared divided by 7x minus 12. Okay, so there's two types of logarithmic equations. There's equations where it's log on both sides, and then there's equations where it's log equals a number, which is what we have right now, because 0 is a number and it equals a logarithm. In that case, you need to change it to exponential form. So again, I know that this has a base e. So basically, e to the 0, because that's what this was, equals this whole thing. Now, anything to the 0 power is equal to 1. Doesn't matter whether it's 1, 2, 1,000, a million, the letter e. Anything to the 0 power is 1. So I'm going to turn that into a 1. Okay, next, so I'm running out of space. So I'm going to do this and keep writing on this side. This isn't a denominator and I don't want it to be, so I'm going to multiply this whole thing over to the other side. The good thing is that multiplying by 1 is going to keep it the same. So now I have this. So now it's a quadratic equation. As soon as I see x squared, I need this to equal 0 in order to solve. So I'm going to move these back over, but by doing opposite operations. So I'm going to subtract the 7x and add 12. So that gives me x squared minus 7x plus 12. And then we factor. So I'm looking for two numbers that multiply to 12 but add up to negative 7. So that's going to be 3 times 4. Yeah, and then they're both negative. So when you solve this, x equals 3, x equals 4. Those are our two answers. You need to write them both. But do be careful of, especially with logarithmic equations, so these are all log, is that they are in the domain, and it even says it in the problem, in the domain of m. So I'm actually going to write right here, what you need to check for when it's logarithm specifically is that the argument, so like that x, has to be greater than 0. And in this argument right here, 7x minus 12 has to be greater than 0. So this one is already solved. This one let's do this one very quickly. So 7x is greater than 12. I just added 12 to both sides. X has to be greater than 12 over 7. So I don't know exactly what that is as a decimal. I know that, so like that way you know what I'm thinking. 14 over 7 would have been 2. So this is 12 over 7. It's a little bit less. So I would take a guess that this is probably about 1.8, 1.7. Like I said, it's pretty much a guess. So that restriction, x is greater than 1.8, that has to be something that holds true. But the good thing is that both of our numbers 3 and 4 are past 2. So yeah, they're both in the domain. They're both correct answers. Okay, and then that is it for FRQ4.